welcome everybody here. I think I know a lot of the people, but for those of you who are new to us here from the group, I'm Greg Deerline, faculty member in Civil and Environmental Engineering. On behalf of our department, I'd like to welcome you to this Shah Distinguished Lecture. It's really great to see everybody here today. Before we get to introducing today's speaker, I'd just like to say a little bit about this distinguished lecture. It's made possible by a donation from the Shah family, which supports this lecture, also supports a fellowship in our department, fellowships in our department, some staff awards and things like that. The endowment for this was set up by Haresh Shah, who I'm delighted is here to join us today. So I'd like to say, and just to say a couple of words about Haresh. It was 50 years ago that he and Jim Geer co-founded the Bloom Earthquake Engineering Center through an endowment from John Bloom, one of our graduates. And even in setting up the center, Haresh even saw at the time moving beyond what we structural earthquake engineers do, the physical things, but to start to look more regionally in the societal and risk analysis, things like that. And then over his career, his academic career, Haresh and his students pioneered new risk assessment technologies, starting in earthquake engineering, but going more broadly, led to the formation of the company Risk Management Solutions, which many of us know. Also, the U.S. HAZIS type program. These sort of technologies first developing, looking at seismic risk, but again, branching out to other ones. So Haresh has kind of worked in this arena and had a huge impact through him and his former students and companies he's been involved with and so forth. Another one of Haresh's passions, though, has been on earthquake safety around the world. The UN had a decade on natural hazard reduction. I forget what decade that was, but during that, Haresh and a few colleagues founded the World Seismic Safety Initiative to kind of draw attention to seismic safety issues around the world, recognizing that when you look at the tragedies that happen with natural hazards, of course, they hit all countries, but they impact mostly those countries that are economically disadvantaged, least prepared to deal with it. And Haresh has always been about broadening the perspective of natural hazard reduction toward that. And indeed, many of our Shah distinguished lecturers over the year, we currently have Veronica Cedillos, who from Geohazard International was last year's lecturer, whose nonprofit kind of works in this arena, which is related to the work we're going to hear today from the United Nations. So it's been a great tradition, and I think one that students and researchers were all interested in. So getting back to the topic at hand, introducing today's speaker. Really delighted to introduce Kamal. As you can see here, his current role is a special representative to the Secretary General of the United Nations on Disaster Risk Reduction. He heads the UN Office on Disaster Risk Reduction, like looking at issues around the world. He has 3 decades of experience in disaster risk reduction. I think starting out with his work probably first in India, looking at earthquake engineering, and in fact, prior to his current role here for a number of years, was the head of the disaster risk reduction in India, but also he's worked previously and broadly with the UN and other agencies, looking at things in Southeast Asia. We were talking earlier today, the last big El Nino in the late 90s, devastated, caused big wildfires in Indonesia and things like that. So the whole field of disaster risk reduction, looking at the whole kind of more broadly, and of course, things related to climate impacted risks are getting worse and worse as we go. I just wanted to say a couple things. He has, if you Google him, you'll find from the UN, he has a site where he puts op-eds up, which are really kind of fascinating, kind of short pieces. They're on all sorts of different topics. He has ones on, looking at risks in general, earthquake risks, tsunami, wildfire risk, also looking at issues of AI. I just wanted to read 2 quick quotes from a couple of those op-eds, and then I'll let him take the stage. Kamal's academic training early on is as an architect, and he worked in urban planning. So I think one of those op-eds talked about housing, and he says, successful housing reconstruction is not just about the buildings. It sits at the intersection of culture, belief, livelihoods, social relations, local governments and economy, finance, building materials and skills, and the natural environment. And the other quote I'd like to make is just more generally that at the UNDRR, disaster risk reduction, Our goal is to support countries in adopting higher resilience standards and practices so that hazards do not escalate into costly disasters. Failure to invest in resilient infrastructure in this era of climate change is perhaps the greatest risk of all. So with that, I'd like you to join me in welcoming Kamal to give our lecture today.
Thank you very much, Professor Dalen. And thank you to Stanford University for inviting me for this distinguished lecture. I don't know how distinguished I will be able to make it. I am also very happy to have Professor Shah in the audience, whose fund supports this lecture. He is a doyen of earthquake engineering, disaster risk reduction in general. I met him more than 25 years ago when he was the president of World Seismic Safety Initiative, and that has really had much greater impact globally than probably even he imagines. It has had many spin-offs across the world. It has inspired action in so many places. And the work that RMS does, RMS's spin-off, RMS India does, it's really taking risk assessment to scale across the world. It has really redefined the practice of disaster risk reduction. It's also really wonderful to reconnect with my friend, Professor Dr. Brian Tucker. He led Geohazards International, again, someone I have known for almost 3 decades now. The impact of his and his organization's work, now ably led by Veronica, is enormous. There were 150 schools in Kathmandu Valley which were retrofitted under the guidance of GHI with National Society for Earthquake Technology. When the earthquake of 25th April 2015 occurred, not one of them collapsed. So if you needed evidence that investing in risk reduction pays off, it's available. So really great, and also across many parts of the world, just as we speak, colleagues from GHI are working in East Timor, looking at resilience of hospitals. There are other friends, my friend from my previous life, Garima Jain, also a postdoc looking at risk reduction in coastal areas, and so many others. And I hope I'll make new acquaintances and there will be many opportunities to collaborate. So I want to start by some good news, and I'm very quickly going to run out of it. But let's start on a happy note. So there has been a remarkable progress globally in reducing disaster-related deaths. If you look at these 2 decades on my slide, there is reduction in deaths up to 65%. In some parts of the world, for certain hazards, the reduction in mortality is more than 90%. There are some extreme hazards that do not even make a national news now because they've become so normal, and our preparedness systems, our early warning systems have improved so much. So I think there is something to celebrate in the work that we've done on disaster risk reduction as the disaster risk reduction community. But I have to say that this progress cannot be taken for granted. This needs to be consolidated, and it comes with at least 2 qualifiers. There's a third qualifier, which I'll talk about later in the talk. The first qualifier is that this duration is too limited to observe. Low frequency, high impact events such as large earthquakes and tsunamis. A decadal observation is not enough. Maybe mortality risk is actually very high. And 2005, 2014, 2005, in this period, we haven't had a major tsunami. So I think we should not get complacent. There is still very high risk. And the second point I want to make is that just in 21st century, there have been several events where in a single event, more than 100,000 people have died. And Indian Ocean tsunami is one. Kashmir earthquake of 2005 is another one. 2010 Port-au-Prince earthquake is another one. So the risk of very high mortality from single events is still very high. Let's celebrate this success, but consolidate this progress and really recognize what this data tells and what this data hides. Now, the good news is over. Uh, so if you look at number of people that are getting affected in terms of displacement or in terms of people who lose their houses, there has been very little or almost no progress. We often compare hurricane events, cyclones of 15 years ago and now, and we show that mortality is down dramatically. But if you look at people without houses, it's almost the same as it used to be 30 years ago. Most recent example, Jamaica, cyclone, Hurricane Melissa, very good in terms of life saving. I mean, that kind of hurricane, remember Hurricane Mitch of 1998? Similar, that would have killed many more people earlier. That's in two digits. But economic impact, enormous. People still without houses, small businesses still not back to work. So the impact, which goes beyond saving lives to saving livelihoods, economic impact is really enormous. And if you put it all together and look at not just the direct losses, but also indirect losses, so I'm counting not just the cost of a bridge washed away, but if it is not built for 3 months, the economic impact so that people don't have access to markets, livelihoods are affected. If you take all of that into account, it comes to something like $2.3 trillion. In nominal terms, the global GDP is right now $105 to $110 trillion. So 2% of global growth is knocked off by disasters. And if we have to reduce poverty, and for reducing the poverty, we have to, if growth is the paradigm, there you are. You cannot reduce poverty unless you manage disasters and reduce disaster-related losses. Here, of course, this is just aggregate number, but when you look at individual households, individual businesses, the impact is even more stark. There are people who've, through years of hard work, government support, interesting, effective development programs, have accumulated enough household assets, have means of livelihoods, and come out of poverty, and disasters put them back in poverty. Poverty reduction is impossible without investing in disaster risk reduction. And this $2.3 trillion is also an opportunity cost. This is what you could do with $2.3 trillion in every year. Just look at one top left corner. $420 billion could send every child to school across the world. We could solve the problem of closing the education gap globally. So this is not just numbers. It's not just aggregate impact in terms of dollars, but it's also opportunity cost in terms of what we could do for humanity with these resources. And for many countries, especially small island developing state, least developed countries, it's really a downward spiral. You don't invest in disaster risk reduction, you have huge losses. If you have huge losses, your income also reduces. When your income reduces, you have even less money to invest in risk reduction, and it's a downward spiral. The case of Jamaica, $8.8 billion lost, needed for reconstructing. That's about 40% of the country's GDP. And this is not the worst any small island developing state has seen. It could be a lot worse than this in many countries. Jamaica has had a very good reputation for very responsible fiscal management at the national level. They've managed their debt very well. They reduced it from 130, 150% to 67%. And all of that is jeopardized by one single event. The event occurred in October last year. It's been 7 months, and there's still only initial steps for reconstruction and recovery. Imagine the suffering of people who are affected, people who are without houses, people who cannot reopen their shops, the huge impact on tourism because tourism infrastructure is impacted, and hence not only businesses, government also has less revenue. So it's really important to see this problem not as a fringe problem, not just as a boutique humanitarian problem, but a central problem of our times. The other point I want to make is that the number of events that are occurring that are causing huge loss of lives and livelihoods is increasing. If you use 2015 as the baseline year, it is expected that at current rate by 2030, there will be 40% increase in the number of events. So even if the mortality is reduced, especially from weather and climate related events, it is likely that economic impacts with current trajectory will continue to escalate. There is one more problem which is becoming more and more apparent globally, which is that we cannot look at risk in location, in one sector, to one capital asset, to one community. Everything is connected to everything, and those interconnections are becoming more and more complex. So if something happens to your power infrastructure, it ripples across all the sectors across multiple geographies. And it is not just for advanced economies, it happens in poor economies as well. A cyclone occurs, the power infrastructure is knocked off for 3 weeks. The power backup for mobile systems, the cell phone towers, is only 9 hours. After 9 hours, cell phones don't work. When the cell phones don't work, ATM machines don't work. When ATM machines don't work, people don't have access to their own cash. They're not looking for assistance. They want their own cash so that the market can begin to function. So local markets collapse. So these interconnections are really complex and they affect everyone. One of my favorite phrases these years is that whether you're rich or you're poor, whether you live in developing country or a developed country, whether you live in Eastern Hemisphere or Western Hemisphere, everybody is now living downstream. You don't know what you are exposed to. The interconnections are such that, events taking place elsewhere can affect you. So it's really important to take that into account, that it's not just risk in location to a particular asset, but it's really something which has become much more systemic. One example, a few years ago in 2022, Tonga, there was a volcanic eruption which affected undersea cable. They were disconnected. The communication was disconnected for several weeks. And mind you, this network is not the most critical for the world. Just imagine if this event occurs in a place where dependencies downstream, upstream are much higher. It can really affect everyone. Just last week, my office with the International Telecom Union produced a report on how natural hazards are creating new risks, will create new risks for the digital infrastructure on which everything depends. If there is a disruption in digital infrastructure, 90% of human activity will come to a standstill. I would encourage you to look at that report. It begins by presenting 3 scenarios. They look like worst case scenarios, but they're all very plausible scenarios. And I reckon that it's not a matter of if, it's just a matter of when such things would happen. If there's a space weather, it will disrupt satellites. Everything, all connectivity will go haywire. If there is extreme heat which exceeds a certain number of days in data centers which are located in hot locations, it will affect everyone. And you can actually see how the ripple effect will carry on. Similarly, if there is geohazards like Tonga, what I told you, in some other location, it could really have, ripple effect across multiple sectors and geographies. And of course, there are new risks. I put that in quotes new because they are not exactly new, but we've become a little bit more aware. And in that, I think extreme heat is really an important hazard. It's really creating problems across the world. The impact of it is across sectors. A lot of the work so far has been focused on determining heat thresholds for what happens to human health, morbidity, and mortality. But the impacts really cut across everything. I was talking to Professor earlier. 50,000 kilometers of Indian railway tracks are exposed to extreme heat. In the hottest month, it is impossible to do maintenance on them. The tracks are so hot. In some other countries, such as in France, in extreme heat situations, you have to actually run the trains a little bit slower to avoid the risk of accidents. And that's just one. What happens to power infrastructure, water infrastructure, and what happens to different occupations, people working in construction industry, traffic policemen. Traffic policemen are a very vulnerable, very exposed group. So it cuts across everything. And our imagination to deal with extreme heat has so far been rather limited. It has focused on cooling solutions. It has focused on alleviating the immediate health impact of heat, but not yet transforming the built environment to be ready for a hotter planet. In many countries, our climate is going in one direction and our built environment is going in the other direction. We are building with a lot of glass. We are not going to be able to air condition our way out of this problem. It really requires fundamental shift in how different sectors of economy are responsive to hotter conditions, starting with a very different kind of built environment. Of course, I just want to reiterate a classic a disaster risk reduction take on this, that everything is not about the hazard. It is really important to talk about how we are exposed to those hazards in terms of where we build and how we build, who is vulnerable, why they are vulnerable. So it's really important to look at everything, and it is underpinned by a whole host of social, economic, cultural, political factors. So now let's talk a little bit about what we can do. My office, one of the things that which is a successor of the decade that Professor Shah shaped in the 90s, is a custodian of a global framework. It's called Sendai Framework. It has got 7 targets to reduce the loss of lives, reduce number of people affected, economic losses, infrastructure disruptions, and increase the number of plans and strategies at the national, subnational levels, increase access to early warning, and increase international cooperation. The situation right now, I mean, I already talked about mortality, is as follows. In 2025, we've got 2 greens. We have a lot of plans and strategies now. The access to early warning is much better now than ever before. If you live in a cyclone, hurricane, typhoon-prone area, the chances of dying now are a third of what they were 15 years ago. The improvement in early warning is really tremendous. It's not just for typhoons, but for other hazards as well. I don't know how many of you remember the July 2025 earthquake in eastern Russia, which triggered a tsunami, which the exposure was here, west coast of the US, many islands, Japan, and the warnings reached people, within a matter of half an hour. This was not possible just, 10 years ago. And that's the Pacific. I think in the Indian Ocean, the tsunami early warning system has improved a great deal. So a lot of progress there. But if you look at some of the other things like economic losses, number of people affected, there is no progress. And the second column there is my hope that by 2030, at least turn the reds into oranges. Let's begin to turn the tide on economic losses. I think that's very difficult because it requires deeper transformation in our economies, in our societies. Whereas saving lives is also difficult, but it can be done relatively quickly. So I think that's where we are globally. In order to do this, I think it is really important that all development investment, all investment decisions take into account disaster risk in a comprehensive way. We understand risk not just in location, but of systems. The added complexity to this is that many things are becoming more and more uncertain. So in the context of uncertainty about what is the future risk going to be, especially where the risks are being modulated by climate change, what is the kind of investment you make, especially in infrastructure systems where Once you make an investment, that investment is locked in for a long time. So what is the new imagination we can bring to this? This really requires a systemic thinking, not just looking at one sector. What happens to roads affected, happens to coastal environments, and what happens to the floodplains. There are a whole range of interconnections that we need to talk about. And how do we bring to our practice of planning, designing, and constructing some adaptive approach, so that we can, as we understand more about those risks, we can begin to adapt. How do we incorporate nature-based solutions into some of our resilience building efforts without really pursuing nature-based solutions as an ideology? It really has to be done in a very deliberate, evidence-based manner. There are many examples of how embankments combined with mangroves are building resilience in coastal areas, realizing that it's not one or the other. You have to imagine gray and green infrastructure in totality and not separately. The other point is that so far, a lot of the work on disaster risk reduction has been driven by governments, public sector entities at the national, subnational, local levels. Now we know, it's very clear that most of the systems are owned, operated, built, designed by private sector. So how do we bring private enterprise into this discussion? This morning, we had a very good interaction convened by Professor on engaging the private sector. And one of the things that the private sector said, that they asked me, what is it that you want us to do? And my answer is, the first thing is that you take care of your business. It's not philanthropy. You make your business more resilient, and look at its sustainability over the medium to long term. Don't just pursue the bottom line every quarter. Look at how it is going to be more resilient over decades. And then you begin to take care of your customers, you begin to take care of your own employees, you begin to take care of your communities, and we begin to build a more resilient system. And of course, then, how can we bring the energy, imagination, resourcefulness of private sector in finding solutions to problems that are becoming more clearly defined now, and also, some measure of corporate social responsibility. Of course, what we've seen in the last few months, in last few years, supply chain, everyone is connected to everyone. We don't know, so many things that we consume come from where. There is this example a few years ago in Suez Canal, because of sand and dust storms and lack of early warning. One ship, was not able to steer very clearly through Suez Canal, and then it basically blocked the canal, and it disrupted global supply chain for weeks. I've been to Suez Canal after that and seen how Suez Canal now is a big user of weather and climate early warning, and how they are actually, and it's not just top down that you tell those who run the ships about this is the warning. Really looking at what is it that the ship owner wants, what is the kind of information they need, when they need, what is the lead time they want. So it's really important to look at supply chain issues as well. And of course, our institutions are using a paradigm of 20th century to solve the problems of 21st century. It is not possible to do that. It is really important that institutions become more responsive, the governance becomes more adaptive, rather than driving decisions top down, rather than being maximalist on regulation. Really take a thoughtful, consultative approach. The history of regulation on disaster risk management is full of examples of negative, unintended consequences. If you are a policymaker, you need to have more humility than anyone else, because what you do has lots of impacts on others, and it must be recognized that you don't know everything. You cannot have deterministic regulation to regulate everything to the last dot. it is really important that governance systems really become more inclusive, more transparent, more accountable, more deliberative and consultative in laying the foundations. And of course, everything is about trust. The early warning, any early warning which is not trusted, however good it is, it will not work. So, how do you design many of these systems ground up? Talk to people as to how they make decisions. What is it that they need? What are the whole basket of risks that they are faced with, in which risk from disasters is only one? And how do they prioritize that and design systems in an inclusive way? Wherever it has been done, I have seen examples of it recently in Tajikistan, in communities. It really brings results not in decades, but in years. You can actually see the next rainfall season much better. And empowering the agency of people is really key. I'll just give you one example. In the 70s and 80s in South Asia, in many countries, cyclones were killing many people. And there were big programs, many supported by multilateral development banks, to design and build cyclone shelters. Those cyclone shelters were designed without consulting communities, so where they should be. They were owned entirely by the state. So when an event occurred, you couldn't find the keys. Um, and if you were lucky and you found the keys, they were so dirty inside that nobody wanted to move there. Now come to the 21st century. In the same region, now cyclone shelters are designed. They're called multi-purpose. They're not owned and managed by the government, but they are managed by the communities themselves. There is a small trust fund to maintain those. So those are used for wedding and other community occasions. So when the event occurs, people already, they've been going there every alternate week. So it's not an unfamiliar facility. It's their facility. They own it. They know how to use it. It's reasonably well maintained. And you see the impact of that. The evacuation rates have improved. Of course, there is a role of, good early warning, timely early warning as well. So working with people is not something optional. It is actually the starting point. So just a few additional thoughts. I think the whole notion of how do we be a bit more cognizant of our own biases about risk and uncertainty, and not just be intuitive about disaster risk reduction efforts. It's really important to bring out different dimensions of risk and communicate that effectively. I think in this regard, the whole work that has developed in the last 20 years on probabilistic risk assessment, etc., how do we make it all come to life for people who are going to use it, rather than only communicate it in narrow, sophisticated, yet only scientific terms. So I think risk communication, communicating risk so that people can relate to that information and situate that in their own day-to-day life is extremely important. The other point I want to make is that culture shapes risk. We really need to understand that different cultures have a different approach to risk. They have a different understanding of risk, and that's our starting point. This is not to say that culture should not be a cop-out. If a culture of a community is that, they want women to behave in a certain way, even when a hazard is occurred, we need to correct that culture. We need to sort of push back, and we need to be more inclusive, etc. But at the same time, you understanding culture, the culture milieu of a community is really a starting point from on which we need to build our disaster risk reduction efforts. And very relevant to this group, it is not just an engineering problem, although I'm the guest of an engineering faculty here. But since morning, I've had discussions with people working on sustainability, people working on design. So it's really important to have get out of the comfort zone of our own disciplines. We want to know why people build the way people build, anthropology. why building codes are not being enforced, governance, what capacity is needed to build for a certain level of resilience in a particular area, engineering. So it really has to be how do you communicate risk, communication. It really has to be an all of society multidisciplinary approach, and it can be done. It is messier, it is much easier to just stick to what you know and just do that bit, and hope for the best. But once you do it, I think it has better outcomes, and it is more sustainable. So I think the opportunity here at Stanford is to really pursue that interdisciplinary, multidisciplinary approach towards risk and resilience. And this is where universities bring together people. I think one thing which is very good that in my brief stay at Stanford I can see is that you are quite applied. You're not afraid to discuss, engage with policy, practice. So here we can bring science, policy, people together. For example, we may be talking about new technology for making buildings heat resilient, new systems for cooling. But we have to, in the same breath, talk about who is going to do it, what skills are needed, who will put the money in it, so finance. What is the role of public sector? How will regulations support that kind of scaling? How do you make a business case for it so that somebody makes money and there is incentive for this? All of that conversation needs to happen around one table. It cannot be that I'll just work on my part of delivering a good cooling solution and hope that it will find market. If as they say, hope is not a strategy. It's hope is just hope. So it's really important that we identify problems and approach them in an interdisciplinary way. And now I don't have any conclusion. I just have a question for Stanford. How will you shape a resilient future for not just yourself, for future generations? Thank you very much.